This is my take on preparation for testing for something like an AM2 assessment style exam. So this is a normal circuit. We've got point A, point B, cabling in between. Faults on an assessment are always going to be switched in by a bank of switches, so you'll never see a fault at the actual thing. So we can just check that we've got continuity from live to live, earth to earth, neutral to neutral, and if you wanted to check everything, you could check all of the combinations. So we've got a good circuit. It runs properly from point A through the wiring to point B. So we're now going to have something where maybe an item of equipment isn't working. So we know really for something not working, there's got to be an open circuit. So I'm going to go back and start everything again. I'm going to go from neutral to neutral. I've got a circuit. CPC to CPC, I've got a circuit. And then when I go live to live, there's an open circuit. I'm just going to check across everything else, and I'm going to check from this end back across the other combinations. So it seems to me that I've got an open circuit on the line conductor between point A and point B. Because I don't know what's going on there, I'm going to suggest that I'm going to need to replace this cable, and then once it's been replaced, I'm going to need to retest it to make sure that I've got that circuit back together again. A similar fault that might catch people out quite easily would be a cross polarity. So again, here's a standard circuit. I'm going to check now. I'm going to check line to line, open circuit, CPC to CPC is continuous. And then I've got neutral to neutral is an open circuit. So it's looking like I've got an open circuit on both the line and the neutral connectors between point A and point B, but it's my understanding you should only ever have one fault. So you shouldn't have a fault between two conductors. So I'm just going to check that I've got line to, I've now got continuity. If I go back and go that side line to, so I've now got cross polarity. It goes out of neutral from one side into the line on the other and out of the line. So what I've now got is I've got now cross polarity between the line and neutral connectors between point A and point B. I would need to replace the cable and then retest it once that's been replaced. So in this instance, the description of the fault might be that the circuit won't reset or the circuit trips immediately when something is turned on. So that's suggesting to me there's a short circuit. So I can go about checking continuity. So I can check, I've got continuity on line to line, continuity on CPC to CPC, but I've got no continuity on neutrals. So before I put that down as an open circuit, I've got to think to myself, it shouldn't really be an open circuit because it's tripping. So I'm going to go back and I'm going to check line to CPC, and line to neutral. So I've got neutral is also connected to the line. I know that line and line is connected, but I now know that somewhere the neutral is shorted into the line as well. I'm just going to check again on CPC. So the only connection is CPC to CPC. And I've got nothing on the neutral. So again, I'm now thinking, so that would be a short circuit between line and neutral, between point A and point B. That's going to need to have the cable replaced and then retested at the end of it. Another fault you might find somewhere might be a high resistance in a joint somewhere. So this might be that potentially a fan is running at a slow speed, or a motor is running at a slow speed, or something like the dull starter, the coil is chattering because it's not getting enough oomph to get it going. So again, I'm going to go, now you might find it's just easy to see with a multimeter on this one. So I'm going multimeter on continuity. I've got nothing, so literally proper closed circuit on line, proper circuit on CPC, but when I go to neutral, I get a continuity reading, but if I check the resistance, I've got 8 ohms. So that's telling me 8 ohms is way over what it should be. I mean, if you did calculation on resistance, it's going to be practically nothing for you know, on this case, a short piece of cable, but even on a long run of cable, you're not going to be talking about 8 ohms of resistance on this. So that's telling me that I've now got high resistance between point A and point B. The cable's going to need to be replaced. In the real world, you might find that one of these joints is loose, but it might well be somewhere along the rest of the circuit. So I can't see that. So it's still going to be replace the cable and at the end of that retest. So I've done everything with continuity on a continuity tester, but again, just using continuity or resistance ohm settings on a multimeter, you'll see that in a normal circuit, you'll get a continuity beep, but you'll get a 0 reading, or as close to 0 as you can get. If you had an open circuit, any one of those would be giving you the open circuit. So you know straight away that that will be the reading for an open circuit. That will be the reading for a healthy circuit. And we've seen already that anything over about 2 ohms is going to be probably a high resistance joint. The other test you could potentially use for short circuit is to do an insulation resistance test. So I've got an insulation resistance tester and I've got it set on 500 volts on a 200 mega ohm range, and I've turned it on to give me a permanent test. So with the probes open circuit, I've got no insulation resistance, so I've got a 1. If I did have a short circuit, it would go to 0. So on the circuit I'm testing, I'm going to start with line, and I'm going to test line to CPC, and I get 1. So I know that's fine, there's nothing shorting out. And if I go line to neutral, I've now got 0. So I now know again, I've got a short between line and neutral, between point A and point B. That's going to need to be replaced and retested. So there's a couple of ways of checking, certainly short circuits or earth faults, same difference just between line and neutral or line, neutral and earth. You can either do it with continuity and you'll pick up there's a continuity between it, but if you want to check that's exactly right, then you can do an insulation resistance between the two.